Hi, and welcome to TEMEKO. In this video, we are going to learn the definition of mass and moment of inertia of an object, and the difference between these two. We will also learn different methods to solve the moment of inertia of an object with respect to a certain axis. Let's get started. So what do we mean when we say that some object has mass of inertia? This is better explained by using an example. For instance, if you have ever seen a car that is accelerating, you may have felt some kind of weird push force pushing your head against the seat. Where does this weird force actually come from? Well, this weird pushing force that you can't see is the force which is caused by the inertia of your own mass that tries to prevent any change in motion from happening. This is the reason why your head is pushed against the seat during the car acceleration. Likewise, when the car stops, you may feel that your body wants to continue its movement, although the car itself has stopped its movement. This is also caused by the inertia of your own mass. Let's now see how the force which is caused by the mass of inertia can be expressed mathematically. This mathematical equation is actually quite simple. It can be written as follows. F inertia equals m times a, where m is the mass of an object and a is the acceleration of an object. Keep in mind, however, that this force is not an actual force but a fictitious one, because it's caused by the inertia of an object. Now that you know what mass of inertia is, some of you may be thinking how it differs from the moment of inertia of an object then. Well, the main difference is that where the mass of inertia tries to resist a change in linear motion, the moment of inertia resists any change in rotational motion. One good example where you may have experienced the moment of inertia of an object is when you have driven a bike. You may know that when a bike wheel rotates slowly, then it easily tips over, but if a wheel rotates much faster, then it doesn't tip over that easily. What can be the reason for this? Yes, you guessed it right. It's the moment of inertia of a wheel, and more specifically, the resisting fictitious moment caused by the moment of inertia of a wheel. We can express this fictitious moment by using the following equation. M equals I times alpha, where I is the moment of inertia of an object and alpha is the angular acceleration of an object. We can also express the moment of inertia itself mathematically as follows. I equals integration over m of r square times dm, where dm is a mass element of the body, whereas r is the moment arm, which is the perpendicular distance from the z-axis to the arbitrary element. Most often, the object is made, however, of different materials, which causes the object to have a variable density. In this case, we can express the moment of inertia by using volume elements for integration as follows. I equals integration over v of r square times rho times dv. In case of density rho being constant, we can move rho in the front of the integral. Luckily for you, however, in most cases you don't have to use these integral equations to solve the moment of inertia, because there exist more simpler equations in the table books that you can utilize. You can also obtain the value for the moment of inertia of the object directly from 3D modeling software while you are doing modeling work. The important thing that you should, however, consider is to check which axis the value or equation of the moment of inertia belongs to. One way that you can also determine the moment of inertia of the object is to use Steiner's rule, which is also called parallel axis theorem. The theorem tells us that if we already know the moment of inertia with respect to the axis which goes through the center of mass of an object, then it's also possible for us to solve the moment of inertia with respect to the parallel axis. Therefore, we can write Steiner's rule as follows. I equals Ig plus m times d squared, where Ig is the moment of inertia with respect to the center of mass of the object. M is the mass of the object and d is the perpendicular distance between the parallel axes. From the equation, you can make one statement, which is that the moment of inertia has the smallest value when it equals the moment of inertia with respect to the center of mass of the object, or when the distance between the parallel axes, d, is equal to 0. Hopefully, after watching this video, you know what is meant by the mass of inertia and moment of inertia of an object, and you know the difference between these two. You also know what kind of methods can be used to determine the moment of inertia of an object, of which one of the important ones is the Steiner's rule, that is also called the parallel axis theorem. Thanks for watching and have a nice day.